Welcome viewer and welcome to Artistry. My name is Ndungu from West Technical Training Institute, and we are taking on electrical installation. Last time we discussed about safety, and we found out that due to the nature of electrical energy being risky, we need to take some steps to allow or to reduce the risk of the risk of electric shock. Now let us see what is electric shock. Electric shock is when current flows through your body, and in one way or another it immobilizes you, and because of that there is a need to reduce the chances of an electric shock. And we said that electric shock is when you touch a live part and whereby current flows through your body. So we see some of the steps that has been taken by the industry to reduce the risk of electric shock. Number one, is earthing. Earthing is simply connection of all exposed metalwork of the installation to the general mass of the earth. Naturally, the general mass of the earth is at a zero potential. So when anything is connected to the general mass of the earth, it is going to be at zero potential, meaning that it is not live, or it cannot be live. This is because all metal parts have the chance, or all metal parts can be electrically charged, and when they are electrically charged, they assume a potential, and if you come into contact with those metal parts, then you are going to get an electric shock, and that one might not be a very pleasant experience. So by earthing, we make sure that all exposed metal parts forming part of the installation, or is part of the installation, be it the equipment or any metallic part or any metallic framework in an installation, is supposed to be at zero potential. And how do we do this? Now, this is what happens when you have an installation whereby you have maybe something like a cooker or electric iron. These equipment, though they are using current, they have a metallic body, or they have a metallic body. So they have a metallic body, or they have a flame that is made of metal. And from what we know is that all metallic parts can be electrically charged. So we have to take caution so that even if these metallic parts are electrically charged, they remain at zero potential. This is what is done. All the metallic part is connected to the general mass of the earth, via a CPC and another electrode, such that the metallic part of the equipment will always remain at zero potential, meaning that they reduce the risk of the part being electrically charged and therefore giving an electric shock. So the other thing that is done, number 2, the other part is the use of protection gear, and here we use fuses and MCB. Now this is what happens when you have an electric fault whereby the live conductor is in contact with the metallic part of the equipment. What should happen is that there should be a very low resistance pad to pass this current. And once the current is passed, the protection equipment, that is either the fuse or the MCB, should operate. And once it operates, it should isolate. It should isolate the faulty part. Should isolate the faulty part such that you don't get the metallic casing or the metallic framework being electrically charged, because the protection has operated and the MCB has isolated the faulty part, and by doing so we reduce the risk of an electric shock. And this is how the earthing should be done. This is how the earthing should be done. This is what should be understood. This is a transformer from the authority supplying us with power. There are several fuses and circuit breakers in the way, so they are presented by that one fuse. Then we have a neutral link, and this is the equipment. Would it be, let's take example, a cooker. So if by any chance the live part touches the metallic housing of the equipment, what should happen is that because the equipment is earthed, current will flow through the earth electrode, through the CPC, should flow through the CPC to the earth reed, and from the earth reed to the earth electrode, and the other electrode is connected to the general mass of the earth. So the current will flow through this path and goes back to the authority's electrode and back to the neutral point. By doing this, we'll have short-circuited the live conductor, and because when you short-circuit, there is a very high amount of current that will flow. That amount of current will be able to operate the fuse or the circuit breaker. And by doing that, what would happen is that the fuse will get broken, and once it is broken, the faulty equipment is isolated. And even if someone touches here, they cannot get an electric shock, simply because the potential of this metallic part is always at zero potential. So they are not in they are not in any risk of being on a live conductor. So they remains like so. And then it also within a very short time, the fuse or the circuit breaker will operate and isolate the faulty part, and by that the person who is using the cooker remains very safe. There are things that should be noted by consumers, and one of them is that they should always ensure that the installation they are working on for power circuit and all other equipment that are using electrical energy, they should have an earth connection. They should have an earth connection that is working. And you should get a qualified technician to check whether your installation has a proper earthing system, so that in case of such an fault, the person who is using the cooker or any other equipment remains very safe and is not exposed to unnecessary risks of an electric shock. So the other thing should be, other than a working connection, ensure that the earth read is okay, and also ensure that the earth electrode is properly connected to the earth read, and the earth read is connected to the CPC, and then you have a very proper system that is safe. So that's what, or that is what, as consumers of electrical energy, should ensure before operating electrical equipment. That's what should be ensured. The other issue should be on the protection or the protecting equipment. That is the fuses and the circuit breakers. The circuit breakers have no problem because there is no risk of someone is going to tamper with them. But when it comes to fuses, most of the consumers, they don't follow the proper routine of replacing the fuse. They just take a bare copper wire, just take a copper, and they just get a copper wire and replace the fuse. This is very dangerous because the copper wire may not be able to isolate the fault in case of a short circuit or another fault like this that we are seeing here. What the copper wire does is, copper wire is a good conductor. Is a good conductor, and as such, even if it is carrying a high current, it might not be able to disconnect the circuit. So what should happen is, if the fuse is blown for one reason or another, make sure that you either get the correct fuse wire or replace with an equivalent cartridge type fuse. This will ensure that the safety of the installation is still good. Now, this is what would happen if you don't replace this fuse with a proper fuse. Probably you use a copper wire, and there is such a scenario. What would happen is that the current flowing will not be disconnected. It's not going to be disconnected because the fuse is not working. So chances are that in the process of current flowing, the earth electrode at the consumer level and at the authorities level, there might be some resistance. And because of this resistance, what would probably happen is that maybe you have a current of maybe 10 amperes flowing, or let's say 50 amperes. Let's say 60 amperes. Now, if you have a current of 60 amperes and the electrode here has maybe a resistance of 1 ohm, and this one also has a resistance of maybe 1 ohm, the total circuit will have 2 ohms. Now, this would be your the cooker that you are trying to protect, not to give an electric shock, will not be at zero potential, because we know from Ohm's law, I is equal to V over R. Now, V is given by IR. So, if you have a current of 60 amperes times 2 ohms, you get 60 times 2, which will give you 120 volts. Now, this 120 volts will be the voltage at your metallic part, and this 120 can be dangerous. And this one we are just giving an example. The other electrode could be even higher, and it has been seen that some of the other electrode has a higher resistance as up to 10 ohms. And if the other side, this side has another 10, or let's assume that it has another 10, you'll get that the potential of our metallic part here definitely will be quite high. It might be high as 240 volts, which is quite risky. So it is always important that make sure that the fuse that you are going to protect your equipment is of the proper, or is of the designed value, so that we avoid a rise of potential on our protected equipment. That is the metallic part of the equipment, and we have it like so. So ensure that if you want to protect your installation, if the fuse is rated maybe 20 amperes for a particular circuit, ensure that you get a fuse that is rated the same. So to conclude, we are saying that safety begins with us, and because it is inevitable, we cannot we like and we cannot do without electrical energy. It is good practice that we take caution, so that we reduce the chances of an electric shock, which is a very unpleasant experience for those who have not experienced it. And we can do it by ensuring that our installation are, first of all, earthed, and secondly, we use the proper fuses and circuit breaker, so that we ensure that our metallic part of the equipment remains at zero potential without any risk. And with that, we come to the end of the program. I was your presenter, Daniel Ndungu, and stay tuned.